Hello again. If you're watching all this in a row like I am recording it, welcome back, or good for you for keep on going. But we are on section 7.3 now, and the objective for this one is we're going to use normal probability to assess normality. Okay, so we're going to keep on going here. Okay, so I'm going to read all this to you and hopefully make sense of it here in a little bit. It says, suppose that we obtain a simple random sample from a population whose distribution is unknown. We don't know if it's normal, okay? Many of the statistical tests that we perform on small data sets, sample size less than 30 is what we're considering small, require that the population from which the sample is drawn to be normally distributed. Up to this point, we have said that the random variable x is normally distributed, or at least approximately normal, provided the histogram of the data is symmetrical and bell-shaped. This method works well for large data sets, but the shape of histograms drawn from a small sample of observations does not always accurately represent the shape of the population. For this reason, we need additional methods for assessing the normality of a random variable x when we are looking at sample data. Okay, so we're going to use a different test here to show normality of a given set of data. So a normal probability plot plots observed data versus normal scores. A normal score is the expected z-score of the data value if the distribution of the random variable is normal. The expected z-score of an observed value will depend upon the number of observations in the data set. So what we are doing here is we are assuming that our set of data is normal, and then using a test here to look at it graphed in a certain way. And from that graph, we should be able to tell whether our given set of data is a normal distribution or not. So here's how we're going to draw a normal probability plot. I'm actually not going to ask you to draw one by hand. I'm actually going to show you how to do this on your calculator. I have a 83 emulator and a TI Inspire emulator that I have figured out how to do these normal probability plots on. And we're going to use those two programs, or those two calculators in the programs, to graph normal probability plots. Okay, so but if you want to go through and know how to do this by hand, have at it. Here you go. Here's the slide that is for you. Okay, and here is something important. This is how you figure out whether you have a normal probability plot or distribution, is if the sample data is taken from a plot that is normally distributed. A normal probability plot of actual values versus the expected z-score will be approximately linear. So what we are looking at is our set of data to be a linear model rather than, scores scattered out everywhere but along the linear model that we are looking at. Okay, so let's take a look at an example, I believe is what I have next. All right, so in this first example on interpreting a normal probability plot, we're going to look at some sample data and then determine whether the sample data could have come from a population that is normally distributed. So you can read about it here. This is where our information comes from. It's single-family homes that are for sale in a Springfield, Illinois, and they were randomly selected, and here are their listed prices. So what we're going to do is take this information, all of these sets of data, and put into our calculator. So I'm going to get my calculator out right here. I know it's really small, but I can't zoom in any more than this right here. But let's turn it on. Okay. What I need you to go to is the list and spreadsheets. And, well, this right here is not necessary. Here, let me exit out of that one. Oh well. How do you do this? Oh, there we go. I am going to enter in all of my sets of data, but before we do that, we actually need to go up to the very top and put in a title. And I'm just going to put in price. Okay, and now for in that column where you have price, list all of these values here. So I'm going to pause it so it makes this video seem a little bit faster, and you may pause it too and go ahead and plug in your values into your calculator as we work along. Okay, now that I've listed all of my values into that column, now understand that I barely know how to use this calculator. I think next thing we need to do is go to Control Doc. There you go. And we need to add in a page. And that page needs to be number 5 here, data and statistics. So I'm just going to click on number 5. And there you go. There are all of our values listed out here. And I am going to go make my cursor go down to this right here. And I am going to click on price. Okay, there we go. We have our X values along this area is known as price, which were the column of numbers that I put in this list here in my PowerPoint. Okay, the next thing that we want to do with this right here is to create, let's just do a histogram first, because I told you I would show you how to do a histogram with your graphing calculator. So go to Menu, and then Plot Types, and there you go. You see box plots. Right now we have a dot plot, that's what we're on, and here is histogram. We can say, let's do histogram. And there you go. It stretches out those points right there and creates a little bar graph with our frequency being over here and then our prices being here. Okay, you can change the width of your frequency on your table if you go again to Menu and then go down to Plot Properties and Histogram Properties was next. And then, let's see, I think it's bin settings, I want to say. Yes. And then maybe equal bin width. Yes, there. You can change your width to what you want. And I don't know what alignment is all about, but you can change those values to help you in, alignment is where it starts. And it kind of gives us that the starting value is right here. And then the width, let's see, we can change it up a little bit and make it, let's see what happens whenever we change it to that value right there. Let's hit OK. and there. Didn't change all that much, but it did change our width for the range of our sets of data values. So, um, but with this histogram, you can actually see that the set of data here, I would consider it right skewed. Most of our data happens over here, and the peak is right up here. So, well, actually, left skewed is what I would consider left skewed data. Okay, I was right the first time. It's skewed because of this over here. I'll get it right before long. Now that you've seen histogram being plotted on your graphing calculator, let's take a look at plotting a normal distribution, a normal probability plot. That's what we're looking for. Let's take that same data and go to Menu, Plot Type, and right here, number 4 is normal probability plot. Oops. And click on OK. And there you go. It even gives us a little line that we want to follow. And you can see these dots, our values that we have plotted on here are kind of scattered out everywhere along this line. Nothing, almost nothing lies on the actual line that we are given. So what I would say in this case right here that we have, what we're seeing is that the data does not appear to follow a normal distribution just because of this right here, and also because of the histogram that we just previously plotted. It was skewed, and so that skewed data does not show a normal distribution, which would be a bell-shaped curve. All right, let's do another example. Just before we go to that next example, here is a plot of what our data was supposed to look like, and that's exactly what we got on our calculator. Okay, so looking at this next. Okay, so this next example that I have for you, okay, has to do with something to do with biology. I can see that a little bit, and factory workers. But we are given this set of data here, which represents what this information is talking about here. And what it is asking for us to conclude is it reasonable to conclude that the FEV to VC ratio is normally distributed? So again, we're going to take that calculator and we are going to plug in our information. Go here, and I am actually going to, let's see, I don't know how to get this cursor. Anyway, let's see. I am going to try to exit out of this, which it is not letting me. Oh well. We can write over the data that we were previously looking at. Control. Oh, goodness. Let me pause this. Okay, so I finally got things working. I'm going to, again, relabel my column. I'm going to call it the FEV VC data. And then in my columns, or in my column, I'm going to put all of these sets of data that I have here. Okay, so I'm going to pause it again. You guys do the same. Okay, so now that I've plugged in all of my values into that column, again, I am going to go over to this here, and actually, let's go back over. Just going to hit Control Dock and then go to number 5 again. And there we have all of our points scattered out everywhere. And let's see if I can get my cursor. There we go. I want this one here. There we go. There's my values that I plugged in to my column, and then I named my X values on my graph here, what that column name was. And now let's do a histogram again. I'm going to go to Menu, Plot Type, and do histogram. And there you go. There's a histogram. We can change the width of our data to help us out here. Let's see if we can make it look any better. I'm going to say Menu, Plot Properties, Histogram Properties, Bin Settings. Let's do that. And let's make our data start at 0.6, and then I'm going to go by, let's double that, 0.04. See what happens. Okay, see our data changed just a little bit. Now everything is more put together. There's no gaps in between our bars that we have there. But this histogram isn't really telling us all that much as far as we can see here about the normal probability plot and whether this data is normally distributed. So let's look at the normal probability plot. So go to Menu and Plot Type, down to Normal Probability Plot, hit Enter, and there. That looks much better than what our previous graph looked like. There are several data points right along that line that has been drawn in. And also, you can see how there's some points here and there's some points over here. It kind of balances out what we have on our normal probability plot here. So what I would say, since this data is fairly linear to the line that has been drawn there, I would say that this data does appear to follow a normal distribution. So the more linear it is, the better the data appears to be following a normal distribution. Okay, so there is that plot there, and that's pretty much what we got. It's from our graph. Let me compare what I had. Let's look at that. Yep, it's just this line is steeper on this graph right here, but it does follow the same pattern as this one here. I can probably, if I was on an actual Inspire calculator, I would be able to grab the graphs in different ways and zoom and whatnot. Let's try that. We can zoom, Menu, do actions. No. Oh, 5. And do 2 for data. Didn't do anything for us, but sometimes that works. It'll change the graph up a little bit. If there's any data points missing on the graph, it will zoom out or zoom in to where you can see all of the sets of data points that we are putting into the system here. But anyway, I think that is actually all I have for you on this one. We're just plotting the normal probability plots and wondering if it's reasonable to believe that it's a normal distribution or not, according to how linear it is. And yep, and that's it. That's all I have for you on this one. So I'll see you in a bit until you watch the 7.4 one, which is next.